So now we come to the difficult. No, I'm joking. We are going to get into something different from what we have discussed until now, dealing with water issues and actually introducing the so-called water energy food ecosystem, or WEFE Nexus approach, and link it also to the water cycle. I can tell you that this is the very, very first time that these two, WEFE and water cycle, are going to be somehow connected, although it is in our mind, perhaps in the back of our mind, from the very beginning. Why we decided to introduce this in this particular workshop? Because biosphere reserves and protected areas, but particularly biosphere reserves, with their sustainable development component, many times we say that are laboratories of knowledge also. So we can make this connection clear as part of our mission and try to influence at local and regional level policies that actually bring this idea, have understood the power and necessity of integration, because this is the epitome of integration. So I start by saying that WEFE, until recently, a few years ago, we started with water and energy. Water and energy nexus. Where is the, oops, what happened? Oh, no, it's okay. But where is the, it's okay. Sorry for that. Okay, we started with water and energy nexus. We brought some 6-7 years ago food there, and the last 3 years we added, actually we in our group added ecosystems in this. The first time I introduced that in the Ramsar site, in the Ramsar convention meeting, was about 10 years ago, but it didn't fly immediately, and it took a few years. So they consider, still we consider this a novel approach on policy level. But we have not realized how deep is this connection and we need to consider the energy and water interaction, but also of ecosystem, within the water cycle in nature. What is the water cycle? We are not talking about one cycle. In nature, we have at least three cycles, 3 water cycles. The most well-known one, the better known one, is the first, is the evaporation, evapotranspiration from the plants, getting high in the clouds, condensation, precipitation, runoff, and then part of it percolation to the groundwaters and discharge. I'll come to this in a minute. It is this one. So here we need, from the beginning, energy that is used for the evaporation, and this energy comes mostly from sun, and we have the condensation, the transport of in the atmosphere. We have exchange of energy, we have the precipitation, we have all kind of phenomena extremely important for climate change, and we have then the infiltration in springs, groundwater discharge, groundwater storage, fresh water storage, runoff, and discharge, either surface or underwater, water springs. So here we have the first understanding of how much energy and water and the forms of water, the quantities of water, the sites where water is found are connected with energy. And we have to keep that in mind, because this is the key of climate change and policies in dealing with the climate change. I go back for the second circularity. The second circularity is the different seasons, that again are dictated by energy. And again, this is extremely important to remember. That is not the same phenomenon is different in the different zones, in the different climatic zones. And for example, to give you a very clear example, I take, let's say, West Africa or the Mediterranean where we are, and let's say Central Asia, Northern. What you see here we know that from May, actually, I mean, during the dry period, we may have, it depends, here is West Africa, and it is this period, it happens to be the wet period. In other, it is different, it's like in the southern hemisphere. But what is important here is that the evaporation and the runoff, the same is in the Mediterranean, have the same pattern. So during the summer, we have no rain, we have no runoff. Everything is dry. During the winter, we have a lot of rain and we have a lot of runoff. This is not the case in Sweden or in Central Asia. Why? Because we have the snow and water during the winter, it is snow, and then because of the exchange, the climate and the energy difference, the runoff is during the summer. So it is totally different for biodiversity. It's totally different. We have a totally different flora and totally different fauna, totally different systems. We are talking about the same amount of water, but we are talking about totally different distribution and totally different patterns of biodiversity. And these two are connected only because of energy. We have the same amount of water and even the same period of precipitation, but we have different runoff in different periods, and therefore the ecosystems are different, and the way that we have to manage these ecosystems is different. And our presence is different. So all these are important. Then we have the third part, which is even less known. The third part is the geographical circularity. And this is extremely important for climate change because, and energy again. Let me go to that. Here we are. The oceans, the distribution of oceans, but also of climate is different in the various parts of the world. Even, I mean, the differences between the Atlantic Ocean and the Pacific Ocean. The Atlantic Ocean is open. Here is Arctic and Antarctic. And we have the areas of the forest from Amazon and Congo in the same area. So here we have a lot of water, more water than is evaporated. So we have this water, the cool water, moving over below Africa, and at the end of the day, evaporating from here. So in fact, the system generates water here and loses water to the atmosphere here. This is absolutely critical for regulating the climate of the planet. And this is an issue of water energy actually interaction. Now we started changing this. We have less water here, we have more periods of dry seasons changing, and this system has started to be changed. And even small changes here, we have the Gulf stream and other streams started to change even with few degrees, and this creates and will create further disruption in the overall climate in the planet. So the energy-water interaction is in nature critical because all this system is critical for the ecosystems and for the food production. So now that we understand that nature has brought all these four elements together, let's go and see what we are doing, how we deal with that. We have different ministries. Ministry of Agriculture, for example, which asks for more water to be used. Ministries of Energy that plan their own policies for energy, production, consumption, billing. Different Ministry for Environment, for the protection of the environment, and actually all these ministries very rarely sit together to design policies that are harmonious or at least compatible. And this is why we think that it's time to show, at least in laboratories of the type of biosphere reserves, that this is possible and productive, and that this has to be used and promoted. So I get into this integrated approach, and we believe that it's important and facilitates the interrelationships in order, again, to have policies and interventions in these sectors. Now, let me become a little bit more analytic about these interrelationships. For example, we need energy for pumping and supply of water, for cleaning water, for heating water, for wastewater treatment, for desalination. And also we have polluting from industries related to energy production. We have pollution of water. We have from mining, from refining, all kinds of production that, and don't forget, quality and quantity of water at the end of the day is the same. You may not consume quantity of water, but by polluting it, you are doing the same. You cannot use it. So, or you need further energy in order to clean it. The same thing, you need water, obviously from hydropower. In cases, even in the Mediterranean, the Nile, Aswan produces a lot of energy. But also in the Balkans, in Lebanon, and elsewhere, we have hydropower. Cooling is very important everywhere. Cooling for production, energy production. for mining, for refining, for chemicals, chemical production. Water is absolutely necessary for energy production. Waterways for transport of fuels, disturbances due to flooding, droughts, and all kind of insufficient flows are related to energy. It's water contribution, this arrow, for energy. And both of them are needed for food. For food, I need water, irrigation, processing, waterways for transport, food providing by aquatic ecosystems, disturbances used to floods and all the rest, soil erosion, the rest directly linked with food, pollution from agricultural practices of water, land cleaning, and loss of biodiversity, energy. And we get into now the fourth, which was neglected until recently. So I don't repeat this. And here is what is now becoming more and more evident through the climate change. Now the expansion, the policy expansion to ecosystems. Gradually, is because of the rapid deterioration of biodiversity due to agriculture, pollution, and climate change, ecosystems were added to the Nexus. Not yet formally, not even in the Biodiversity Convention. The Nexus is not, it is only now introduced, but is not so clear as we wish. And the energy production consumption is actually shifting to concentrated solar power and other renewable energy sources. And this may change altogether the Nexus balance.